Here's a solution for day 2, problem 1. Given these two functions, find the following. F of x is x plus 1. G of x is x minus 1. So these are function rules for two different functions called f and g. We're asked to find the following. Question A, f plus g of x. This is just another way to write f of x plus g of x, which is probably how you saw this in algebra class. And here in pre-calculus class, we combine it together to look like this. So this means to add together function f and function g. So we take function f, which is the expression x plus 1, and add function g, which is the expression x minus 1. Let's add these together. X plus x is 2x, and this positive 1 plus this negative 1 cancels away, just leaving the expression 2x. So there's the answer to question A. Now question B, we want f times g of x. In algebra class, you probably saw this as f of x times g of x. So this means to multiply together the two function expressions. F of x is x plus 1, and g of x is x minus 1. We want to multiply together these two binomials. We can use FOIL, we can use the distributive property repeatedly, or we could recognize that this is a binomial sum times the binomial difference, which will create the final result of x squared minus 1. X times x is the x squared. Now the outer product using FOIL, x times negative 1 is negative 1x. The inner product using FOIL is positive 1x, and those cancel away, which is why there is no x term remaining in the answer. And now the letter L from the word FOIL, 1 times the negative 1 makes the negative 1. Final question. F, and then we have this symbol here, which is not a multiplication dot, and then the G. This is showing a composition of functions. In algebra class, you saw it like this. What is f of g of x? These are equivalent expressions, just using a different notation. So this means to take function g and input it into function f. It's like doing this. F of, and then take function g, which is the expression x minus 1, put it into the variable for f. So the function f has the expression x plus 1, and in place of x, we're putting in x minus 1, and then the plus 1. Evaluating this out, we get the answer x. To do a composition of functions, you're taking one of the functions and inputting it into the variable of the other function. We're taking function g and putting it in place of the variable in function f. Day 2, problem 2. Solve the quadratic equation by completing the square. Here we have an equation. The left side of the equation is this trinomial. The right side of the equation is 0. We're asked to solve the equation, so find the answer or answers for x. Because it is quadratic, the highest degree is 2, we anticipate 2 answers for x. Now there are different ways to solve quadratic equations. We're specifically told to use completing the square. So how completing the square works is to change this trinomial into a perfect square trinomial. There's a process for doing that, and it looks like this. Copy down the x squared term, copy down the plus 6x term, and take the constant term and subtract it over to the other side to create this equation. So we're starting here, subtracting 2 from both sides to create this. Notice I left some space here, and I did that on purpose because when completing the square, we're going to now add a number to both sides of the equation. To find the number we want to add, we take a look at this number right here. And here's the process that you go through to figure out what number to add to both sides of the equation. Take half of this, which is 3, and then square that. 3 squared is 9. So I want to add 9 into that blank spot, and you must add 9 to the other side to compensate. As long as you add the same number to both sides of an equation, that's a legitimate algebra step. Again, the way that I figured out what number to put here is I took half of this number, which is 3. I did half of 6, which is 3. And then I took the 3 and squared it, which is 9. The reason for doing that is to create a trinomial that is called a perfect square trinomial. A perfect square trinomial factors. In this case, it factors into x plus 3 squared. And that is equal to, and on the right side of the equation, this makes 7. In algebra class, you learned how to take a perfect square trinomial and rewrite it in factored form like this. This is helpful to us because now we can take square roots of both sides to get the answers for x. On the left side, we take the square root of x plus 3 squared, and that just creates x plus 3. On the right side, we want to do the square root of the 7. But to create two answers, we take the positive and the negative square root of 7. A quick way to show the positive and negative square root of 7 is to use the plus minus symbol. Final step to isolate x is to subtract 3 from both sides. We get x equals. Now because the square root of 7 doesn't make a whole number or anything, the fastest way to record the final answer is to write it as negative 3 plus or minus the square root of 7. That's what you get when you combine these together. It's customary to take the integer and put it in front of the plus minus symbol and leave the radical to the right of the plus minus symbol. It's really the same thing as saying plus minus the square root of 7 minus 3, but this can be a little bit confusing if you're at all a little sloppy with how long you make that radical symbol. If you start to get it too long, now it looks like the minus 3 is under the square root symbol. So to avoid that confusion, we put any integers in front of the plus minus symbol and put the radical behind the plus minus symbol. Here's the final answer unless you want to take a calculator and actually evaluate out both of these numbers as decimals. This really gives us two answers. The first answer would be whatever negative 3 plus the square root of 7 is on a calculator. And the other answer would be whatever negative 3 minus the square root of 7 would make on a calculator. Some kind of negative number there. But it's not necessary to do that with a calculator. We can just leave our final answer like this. And in pre-calculus class, we will know that this means two answers. One of the answers coming by doing an addition problems here, and the other answer coming from doing a subtraction problem right there.